Home Alone 2 did an oopsie. Kung Fu Panda did an oopsie. Transporter 2 did an oopsie. So many oopsies. But who wins?
Hello, my name is Jim Bob, and welcome to the 10th Annual Award Movie Ceremony. Tonight, we will be reviewing the worst films demonstrated all year long. Tonight, we will see that plots are important factors in movies, but if the movie has defied the laws of physics, it has crossed a line. Yes. Tonight, we will be joined by the world-renowned critics, Benjamin, William, and Clarence.
Hi, I'm a movie critic, Benjamin, and today we're reviewing Home Alone 2.
Hi, I'm William, and I'm also a movie critic. I'll be reviewing Kung Fu Panda.
Hi, I'm movie critic Clarence, and I will be reviewing Transporter 2.
Our first nomination for the worst movie this year is Home Alone 2. Now, you may be wondering why a movie from 1992 is being reviewed right now, but the incorrect physics of this movie is unreal. Now, let's take a look at one unrealistic scene from this movie. Movie review.
I will analyze the scene of Marv, who jumps on the lever, and Harry, who jumps up because of Marv. How heavy would Marv have to be in order for Harry to jump for so long? First, we calculated the amount of time Harry takes to fall from his maximum height, which is approximately 1.665 seconds. I used the equation. Delta x is equal to the product of the initial velocity times delta t plus the product of 1/2 times the acceleration and delta t squared. The initial velocity at his maximum height is 0, and the acceleration of humans on the Earth is approximately 9.8 meters per second squared. The calculations add up to 13.584 meters. This is how high Harry flew up to. Here, we use the concept of conservation of mechanical energy. Ignoring the sound energy and friction resulting from this event, we can find out that the potential energy of Harry at his maximum height is equal to Mark at his maximum height. The formula for the potential gravitational energy is the product of the mass of the object and the gravity and the object's height. The actor for Harry is Joe Pesci. He weighs about 70 kilograms. Gravity will be same for both people. We found out that Harry's height from earlier calculations. We also found out that Marv jumped from about Harry's thigh to his foot. This is approximately 0.4 meters. Coming back to the potential gravitational energy equation, if we calculate for Marv's mass, he would need to be about 2,211.35 kilograms for Harry to fly up that high. The heaviest human ever recorded was about 600 kilograms, so this scene is very unrealistic. Since the mass of Marv and Harry are similar, we performed a real-life trial involving 2 erasers of almost same mass and saw if the other eraser flew up high. I can even find more evidences of Home Alone being unrealistic. Here we have Kevin dropping a brick from a roof of a 5-story building and hitting Marv right in the face. Now, it does take common sense to know that this scene is unrealistic, but I will prove that by using physics. Will Marv really be fine after getting hit by the brick? Or would he get injured? Kevin drops the brick at 42.324 and the brick lands at 44.961 seconds in the video, but the point of view changes from Marv to the brick, so the actual time that the brick fell was for 1.663 seconds. Using the equation, final velocity is equal to the sum of the initial velocity and the product of the acceleration of the object and the time that was in motion. The initial velocity is 0 as Kevin drops the brick. The acceleration is clearly 9.8 meters per second squared. From the equation, it can be derived that the brick is falling at 16.2974 meters per second. But how much damage is this?
Now that's a lot of damage!
The kinetic energy of the brick as it makes contact with Marv is 1/2 times mass times instantaneous velocity squared. The mass of the brick is approximately 3.5 kilograms. Thus, the kinetic energy is about 464.81 joules. This amount is enough to get Marv killed.
Oh, what a lovely day!
How can this not be the worst movie ever?
The second nomination for the worst movie is
What the
Kung Fu Panda. Even though it's animation, the physics is still unreal.
The scene is when Talon confronts Master Shifu and they fight each other. In the scene, you can see Talon ramming Shifu through the ceiling for the first time, flying in the air for a long time, and Talon once again crashing Shifu's head through the roof. Then, Shifu stands up seemingly unharmed, and Talon lands gracefully on the ground. This got me wondering, how much energy is exerted on Shifu's head? So, first of all, to find this, we can calculate the amount of gravitational potential energy that the jump has. We will be using the equation of kinetic energy equals to 1/2 times the mass multiplied by the velocity squared. The jump is about 10.93 seconds, and because we need to find the velocity before crashing into the roof, we need to divide the time by 2, which gives us the time for just the fall. And after that, we multiply the time by 9.8, which is the acceleration of gravity to give us the velocity. This gives us a velocity of 53.53 meters per second right before Shifu and Talon crashes into the ceiling. And assuming that Talon is 100 kg and Shifu is 10 kg, we can plug in the numbers in the equation. So 1/2 times 110 kg, which is the mass of Talon and Shifu, multiplied by 53.56 meters per second squared, is equal to 157,759 joules of energy. Next, we have to calculate how much energy is being used when they crash into the ceiling. Because to find the total amount of energy Talon can exert with his legs, we need to find out how much energy the first roof crash takes out. Simply speaking, the total amount of energy Talon can exert is the roof crash plus the flight. To solve for this, we will be looking at the velocity of Shifu and Talon after the ceiling crash. Moving on, we can see that in one frame, Shifu moves approximately 2/3 of his body length. One frame in this case is 1/30th of a second. Assuming that Shifu is about 90 cm and 2/3 of his body length is 0.6 meters, Shifu is moving at 18 meters per second after the crash. We can plug this into the equation, which is 1/2 times 110 kg multiplied by 18 meters per second squared, which we get a total kinetic energy of 17,820 joules. This is the amount of energy left after the crash. So we can subtract this number by the initial 157 and 759 joules, which is the kinetic energy of the flight, and we get a remaining energy of 139,939 joules of energy. This is how much energy that the roof takes out of the fall. This also means that Shifu took 139,939 joules of energy on his skull twice and was still functioning fine. To give you a reference, an AK-47 shoots out a bullet which contains 2,180 joules of energy. This means Shifu can technically take 66 of these bullets on his head at the exact same time, if they were evenly spaced out. Everything in Kung Fu Panda is crazy, and Shifu's skull being able to take 66 bullets, how can this not be the worst movie ever?
The third nomination for the worst movie this year is Transporter 2! In this movie, the characters perform some crazy stunts which defies the laws of physics and are unreal. Here, I will be analyzing one unrealistic scene from the movie. In this scene, Frank, accompanied by his partner Lola, drives an Audi car off the roof of a building. In one scenario, we will find how far the car falls downwards. In this scene, the car flies through the air for approximately 5 seconds. Using the equation for freefall, we find that the car falls 122.5 meters downwards after 5 seconds, assuming there is no initial vertical velocity. That means the car would have smashed into the ground by then. A key point to notice here is that the horizontal velocity does not affect the vertical velocity at all, since they are independent of each other. In our second scenario, we can derive a more realistic flight time for the car, which would result in an insane horizontal velocity. We begin by assuming the car flies into the parking lot 2 floors below the roof of the second building based off of the clip. From there, we can estimate that the height of each parking lot is 3 meters high. We multiply that by 3 floors, giving us a height of 9 meters. However, we also have to factor in an additional 2 meters, because the roof that the car flies off of is higher than the roof of the second building it lands on, thus giving us a total height of 11 meters. Next, we can get the diagonal distance traveled by the car. We can see the number of cars that would fit into the diagonal distance traveled by the car between the 2 buildings. As a result, there is around 7 car lengths that could fit into this distance. Since the average length of an Audi car, which is driven by Frank, is 4.736 meters, the diagonal distance is 33.082 meters when multiplied out. Then, using the Pythagorean theorem, the horizontal distance traveled by the car is 31.2 meters. After that, using this equation for finding the vertical displacement of an object, we can solve for the time, which comes out to be 1.498 seconds. If we divide the horizontal distance the car traveled, which is 31.2 meters, by this time, we can get an absurd velocity of 20.823 meters per second. The movie scene itself shows the car flying through the air for 5 seconds. Thus, if the car was traveling at this velocity, it would have traveled for 104.117 meters after those 5 seconds. To put that into perspective, the car would have flown 3 times the distance it covered in this one stunt.
While in the backstage, Jim Bob had to decide who the winner for the movie with the worst physics is. However, after listening to Benjamin, William, and Clarence's explanations, Jim Bob could not decide the winner.
Hey, where is Jim Bob anyways? Jim Bob? Jim Bob, hello? Are you there? Jim Bob? Jim Bob? Oh, Jim Bob? Are you there?
After a few minutes of thinking in the bathroom, Jim Bob devises a solution.
To recap, Benjamin showed that the mass of Marv is unrealistic, and the brick that he took to his skull would have killed him. William showed that Shifu can take an insane amount of energy to his skull, and Clarence showed that the car would have either crashed down or flown away into space. The results were very close, but the winner for the most physically incorrect movie is